This is the key to worksheet topic 5, part D, and this is worksheet number 2 on that topic, part D. So you have 4 quadratic equations, and you want to solve these quadratic equations using the quadratic formula. All right, and then, so again, it says do not use any other method, and then simplify radicals if possible. So let's look at number 1. So number 1, we have x squared minus 4x plus 13 is equal to 0. So we have this quadratic equation, and we want to solve this using the quadratic formula. And so first thing we got to make sure is that it is in standard form, and it is. So remember, a quadratic equation is in standard form if it has this form, ax squared plus bx plus c equal 0. So you want all the terms on one side and 0 on the other. Now, a good idea is this. Once you have it in standard form, then you need to determine what a is, b, and c are. So remember, a is a coefficient of your squared term, b is the coefficient of the first degree term, and c is your constant. And so in this case, if you look at a in here is 1, because that's 1x squared. So I'm going to write a is 1. It's a good idea to write this out. B is the coefficient of x. So b in this case is a negative 4. You have to keep that sign. It's a negative 4. And c is your constant, which is 13. And so all we're going to do now is substitute this into the quadratic formula. And so remember the quadratic formula, let me go ahead and write this on this page. So the quadratic formula is this. And so the quadratic formula, remember, allows you to determine the solutions of any quadratic equation. So if you have a quadratic equation and you want it in this form, then the solutions of this quadratic equation can be found by this formula. So it's the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so that's the quadratic formula. And that formula will give you the solutions to any quadratic equation, whether the solutions are real or whether the solutions are imaginary. Okay, so let's substitute back into the formula. So I get x equals the opposite of b. Well, b in this case is a negative 4. And so the opposite of a negative 4 is a positive 4. Plus or minus the square root of. Now remember, it is in here that you need to use parentheses. So remember, the next part says I have to square b. Well, b in this case is a negative 4. So if I square negative 4, at some point I'm going to end up with a negative 4 times a negative 4, which is a positive 16. So you have to be careful. So b squared should always be positive or 0. B squared should never, ever be negative, all right, because you're squaring it. And a negative times a negative is a positive. 0 times 0 is 0. All right, so it's never negative. Minus 4 times a is 1, times c, which is 13, all divided by 2 times a, and a is 1. All right, so the first thing you should have done. So the first thing is to substitute everything you know. And remember, you have to write it like this. Don't forget about dividing by 2 times a. All right, so because x is equal to this fraction here. All right, let's go ahead and simplify this further. So I get 4 plus or minus. At this step is where you want to simplify the radicand. Now, at some point in another lesson, you're going to learn that this radicand, b squared minus 4ac, is called a discriminant. But for this particular worksheet, it's not needed to know that that is the discriminant. So negative 4 squared is 16. A negative 4 times 1 times 13 is a negative 52. Divided by, and then 2 times 1 is 2. So simplifying 16 minus 52, I get 4 plus or minus the square root of a negative 36 divided by 2. And so it is expected that you go further with this. So the square root of a negative 36, although this is not a real solution, it is imaginary. And you learned about complex imaginary solutions. So you have to say that the square root of a negative 36 is 6i divided by 2. Now, you need to simplify as much as possible. So you are expected, for the way that this looks, where this is 4, this is 6, and this is 2, they're all divisible by 2, you are expected to simplify that further. So if you leave it like this, you won't get full credit, but you'll get most of it. But what I'm looking for is this. 4, 6, and 2, they're all divisible by 2. So in other words, you're going to say 4 divided by 2 is 2, 6 divided by 2 is 3, 2 divided by 2 is 1, and so you get 2 plus or minus 3i divided by 1, which is just 2 plus or minus 3i. So now you didn't have to show this. That's not necessary to show. Did not have to show. Okay? But in your mind, that's what you're doing. So all you had to do is just say this is the answer, 2 plus or minus 3i. All right, so this part you had to show. So that's the work you needed to show. All right, and so there's your answer. So you have two solutions, 2 plus 3i and then 2 minus 3i. Now see how I did it this way, how I noticed that 4, 6, and 2 are all divisible by 2? You could have also done this. You could have done this. All right, so watch. You could have done this. So you could have said, all right, well, I'm going to take this 4 divided by 2, but remember what you have two terms up here. You see that 4 and 6i, they're all divisible by 2. So in other words, you have to say 4 divided by 2 plus or minus 6i divided by 2. And then notice you still get 2 plus or minus 3i, which is what I wanted. Okay? All right, so that was number 1. Okay, so let's look at number 2. Number 2, I have this. I have this problem number 2. I have 3x squared plus 10x equals a negative 2. All right, so first of all, recognize that this is not in standard form. So this quadratic equation is not in standard form, so I have to bring the negative 2 over. So when I do that, I get 3x squared plus 10x plus 2 equals 0. So now it's in standard form, and now I'm going to go ahead and determine a, b, and c. So a is a coefficient of x squared, so that's 3. B is a coefficient of x, so that's 10. And c is your constant, so that's going to be 2. So now substituting into your formula, I get x equal the opposite of b. So remember, you read this as, this part here, you read this as the opposite of b. So b is 10, the opposite of 10 is negative 10. Plus or minus the square root of, in parentheses, b, which is 10 squared, minus 4 times a, which is 3, times c, which is 2. All of that is being divided by 2 times a, which is 3. So I get negative 10 plus or minus the square root of 10 squared is 100. And then 4 times 3, a negative 4 times 3 times 2 is a negative 24, all divided by 6. And so I'm going to go ahead and just kind of do the work here. So this becomes negative 10 plus or minus the square root of 76 divided by 6. All right, now here's where you got to remember, you need to see if you can simplify the square root of 76, just like we were able to simplify the square root of a negative 36. So the square root of negative 1 is this I, 36 is a perfect square, the square root of 36 is 6. Here, though, we do notice that 76 is not a perfect square, but there is a perfect square that goes into 36 besides 1, and it's 4. So watch. So we have 76 divided by 4, and 19 is a prime number, so I can't go any further with it, so the largest perfect square is 4. So this becomes the square root of 4, which is 2, so I get 2 square root of 19. So this becomes negative 10 plus 2 square root of 19, all divided by 6. Okay, now, at this point, there are a couple of things that you can write your answer as. So just like we did this, I just want you to see this, just like we did this, we looked at 4, 6, and 2, and we know that 4, 6, and 2 are all divisible by 2. I can look at this and notice that negative 10, 2, and 6 are all divisible by 2 itself. So this is not, you don't need to show this, so you don't need to show this, what I'm about to do. But in your mind, you're saying this. This is what you're saying. You're saying negative 10 plus or minus 2 square root of 19 divided by 6. So in your mind, you're saying this. Negative 10 divided by 2 is a negative 5. 2 divided by 2 is 1. 6 divided by 2 is 3. And so this becomes negative 5 plus or minus the square root of 19, all divided by 3. All right, so that's one way. Now, what some students did, and it's fine, you can do that, what I'm about to do, or you could have said this. So remember how we did here where we said, okay, I can take this divided by 2 and then take this term divided by 2? Do the same thing here. Do the same thing. So in other words, you're saying negative 10, 6 plus or minus 2 square root of 19 divided by 6, and then reduce. Negative 10, 6, they're both divisible by 2, and so you get negative 5/3 plus or minus. Here, they're both divisible by 2, and then you get square root of 19 divided by 3. All right, so either one of those, either this one or this one is fine. So negative 5/3 plus or minus the square root of 19 over 3. They mean the same thing. Okay? So that was number 2. Let's look at number 3. All right, so number 3. We'll put number 3 here. So number 3, I have 5x squared plus 5x minus 2 equals 0. All right, so it's already in standard form, so I know that, and I know I can easily find a, b, and c. So a is a coefficient of x squared, so that's 5. B is a coefficient of x, so that's a positive 5. And c is your constant, which is a negative 2. And so I get x equal the opposite of b, so the opposite of 5 is a negative 5, plus or minus the square root of 5 squared, b squared, minus 4 times a is 5, times c, which is negative 2. All right, so all I'm doing is just plugging the values back into this formula. All divided by 2a. So all of this is divided by 2 times 5. A is 5. And so then I get negative 5 plus or minus the square root of 5 times 5 is 25. A negative 4 times a positive 5 times a negative 2. So I want you to notice that that's going to be a positive right here. So you're going to say plus 4 times 5 is 20. 20 times 2 is 40. All divided by 10. 5 times 2 is 10. Equal negative 5 plus or minus the square root of 25 plus 40, 65. All divided by 10. All right, now I want you to notice something. So you're going to try and ask yourself, well, can I simplify the square root of 65? Can I simplify the square root of 65? Well, you're going to look for perfect squares that go to 65. Well, one is a perfect square. It goes into every whole number. But for some of you, it may be difficult to determine what perfect square goes into 65. So what I would do is this. In something like this, I would say, all right, I know 5's not a perfect square, but let me see what I get when I divide by 5. So when I divide 65 by 5, I get 13. Well, 13's a prime number and 5's a prime number, so I can't do anything further with that. So that's it. That's all you can do. So the square root of 65 cannot be simplified. And so there's your answer. Now, if you want to write this like we did the others, you could say, all right, now remember the work is not needed here, so don't need to show. You don't need to show this. So you can say negative 5/10 plus or minus the square root of 65 over 10. Now I can reduce negative 5/10, so that's a negative 1 and that's a 2 because they're both divisible by 5. So you could say negative 1/2 plus or minus the square root of 65 divided by 10. So that's the other answer. Okay? All right, number 4. So let's do number 4. Okay, so number 4, we have 2x squared minus 4x plus 1 equals 0. So again, it's already in standard form, so I can easily determine a, b, and c. So a is the coefficient of x squared, so a is 2. B is a coefficient of x, so that's a negative 4. And c is your constant, which is a positive 1. So I get x equal. So let's plug in, substituting all those values back into this quadratic formula. I get the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. So if b is a negative 4, the opposite of a negative 4 is a positive 4, plus or minus the square root of negative 4 squared minus 4 times a is 2, times c, which is 1, all divided by 2 times a, and a is 2. So I get 4 plus or minus the square root of, go and simplify the radicand next. A negative 4 times itself is a positive 16. And then a negative 4 times 2 times 1 is a negative 8. Now remember, b squared should always be positive, so don't make that negative. That should never be negative. All right. All divided by 2 times 2, which is 4. And so I get 4 plus or minus the square root of 8, all divided by 4. Okay, now you are expected to simplify the radicals, because remember the directions does say simplify radicals if possible. Okay, so this one's easy for almost all students. Besides 1, the other perfect square that goes into 8 is 4. So remember, in your mind, you're saying the square root of 8 is the square root of 4 times the square root of 2. So it's 2 square root of 2. So I'm going to replace this square root of 8 with 2 square root of 2. So I get 4 plus or minus 2 square root of 2, all divided by 4. And then, and if you leave it like this, you're going to lose 1 or 2 points because you didn't reduce all the way. So notice that 4, 2, and 4, they all have 2 in common. 2 is a factor. So I'm saying this. You don't have to show this. Don't show this. But in your mind, you're saying this. 4 plus or minus 2 square root of 2, all divided by 4. So you notice that all these are divided by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. And 4 divided by 2 is 2. So then you would get 2 plus or minus the square root of 2, all divided by 2. Now, you could have also done this. You could have said, well, I'm going to go ahead and write these as 2 separate fractions. So in other words, I'm going to say 4 divided by 4 plus or minus 2 square root of 2 divided by 4. And then reduce each of these. So 4 divided by 4 is 1. Plus or minus, okay, these two are both divisible by 2. So 2 into 2 is 1. 2 into 4 is 2. So I get 1/2 square root of 2. Or you can say 1 plus or minus the square root of 2 divided by 2. Either one of those is fine. All right, either one of those is fine. So our 1 plus or minus the square root of 2 divided by 2. Okay? All right, so that is the key to the worksheet on Topic 5, Part D, and this was worksheet number 2.